Congratulations on hitting the end of this chapter where we were learning about smart pointers. We started out by looking at why we need smart pointers. And the reason is we need a better way to manage our heap memory. The traditional way of calling the new operator and calling the delete operator when you are done using your memory has proven to be problematic in that people forget to call the delete operator, and this is going to leak your memory in your C++ programs, and this is really bad. So modern C++ introduces a bunch of smart pointers whose main goal is to solve these problems. And we have looked at three main smart pointers in modern C++. We had a chance to look at unique pointers, we had a chance to look at shared pointers, and we finished the chapter by looking at weak pointers. Unique pointers are set up using the syntax you see here. You say std unique pointer and you put your type in these angle brackets. You pass the variable name and you do your memory allocation as you see here. And once you have the unique pointer, you can really use it like you use any other pointer. You can use the reference operator as you see here. You can use the pointer call operator, and this is going to work just fine. The meat of this is that when the pointer variable name goes out of scope, the memory is going to be automatically released. We're going to see the destructor for dog called without explicitly calling the delete operator. And this is going to make memory management, especially for heap memory, much more easier in your C++ programs. We also had a chance to look at another way we can allocate for memory for our unique pointer. We can go through the std make unit facility, and this is going to dynamically allocate a piece of memory to contain our dog object, and we're going to be managing that memory using this unique pointer here, and this is really cool. We also had a chance to look at ways we could use unique pointers and pass them as parameters to function or get them back from functions through the return mechanism. And we had the chance to look at a few things you really need to be careful about. We moved on and looked at how we can use a unique pointer to manage an array of objects. And again, the syntax is what we saw here. You can go back and look at this again. And if you need to use this in practice, this is really how you're going to be doing this. Once you have the array dynamically allocated on the heap, you can really use it like you use any other dynamic array. We can do our loop here and grab each object in this array and print the information about it. And we can really do all kinds of crazy things. We moved on and had a chance to look at shared pointers. And this is another kind of smart pointer we have in modern C++. And this pointer is special in that it allows copies. In other words, we can have multiple pointers pointing to the same data in memory, and this can come in handy in many situations. Another special thing about these kinds of pointer is that they have a reference counting mechanism. Each pointer you set up is going to increment the reference count. For example, here, if we have 4 pointers pointing to the same data in memory, the reference count is going to be 4. But if any of these pointers goes out of scope, the reference count is going to decrement, and the memory is going to be released when all of these pointers have gone out of scope and the reference count has decremented all the way to 0. So this is the working principle of shared pointers as you see here. We also had a chance to look at the syntax for these. The syntax is what you see here. We say std shared, we say a pair of angle brackets, and then we put the type inside. We can either go through the new operator to allocate for memory, or we can even use make shared to allocate our memory on the heap. Either of these is going to work. And when our shared pointers go out of scope and the reference count decrements all the way to 0, we're going to have our memory released, and this is going to be really cool. We also saw that we can take a unique pointer and turn that into a shared pointer if this is something that is going to be helpful in whatever project you are building with C++. And we do this through a special facility, which is std move. This is going to move memory management right from the unique pointer to the shared pointer, whose reference count is going to be 1. And from this shared pointer, we can create other shared pointers through the copy mechanism, and each copy we create is going to increment the reference count, and we can really use however many of these shared pointers as we need in our C++ application. After that, we looked at different ways we can use shared pointers to manage arrays. We looked at how we can pass shared pointers as function parameters or even use them as return values from functions. We closed the chapter by looking at weak pointers, and we have seen that these are special pointers which don't implement the pointer access operator or the dereference operator. And one might think that these pointers are really useless, but if you happen to have cyclic dependencies in your C++ code, they are going to be saving your day because they don't increment the reference count, and they are going to be allowing your objects to be properly released from memory if you have cyclic dependencies in your code, and we had a chance to play with this. This is really all I had to share in this chapter. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to start and look at operator overloading. Go ahead and finish up here and meet me there.